Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will discuss now the different technologies for improving the performance of extreme cold climate clothing. So, phase change material is one of them. Let us first try to understand the principles of phase change material. So, materials that absorb, store and release heat. Okay. So, during the phase change. So, phase transition types are of solid to liquid, most common, high enthalpy change, and solid to solid, no liquid phase, shape stability is there, and so liquid to gas is there, highest enthalpy, okay, containment changes, and the thermal regulation mechanism is that heat absorption. PCM melts when body or ambient temperature rise, it absorbs excess heat and it gets melt. Okay. And heat release, and PCM when it solidifies, it releases the when the temperature drops, okay, it gets solidifies and then heat release. This is used in case of the extreme cold climate clothing. This mechanism is used. Now, the selection criteria for textile applications are, that is transition temperature. The transition temperature matches with the human body temperature, comfort range 25 to 35 degrees Celsius. At that temperature, the phase change should take place. The enthalpy change, high storage capacity. So, typically more than 150 joule per gram. So, it is the PCM material, phase change material basically which are suitable for textile application is N octadecane. Okay. Transition temperature is at around 28 degrees Celsius. Okay. And paraffin works, it is a 25 to 30 degrees Celsius. These are very commonly used for textile material. PEG 1037 to 40 degrees Celsius. Transition temperature, performance characteristics, response time is typically 2 to 5 minutes. Okay. That in the onset full transition, it takes around 10 to 30 minutes depending on the mass. So, that for during that time around up to half an hour one can be protected by enhancing the heat. Body, it can be it can keep the body warm during full transition, during transition time. So, cycling ability. So, typically more than 1000 time that is thermal cycle it can absorb. So, how to integrate this PCM material, PCM within the textile structure? One of the very commonly used technology is the micro encapsulation technology. So, through micro encapsulation, contain PCM in a micro capsule, and to prevent leakage while maintaining the heat transfer. So, encapsulation methods are there are different types of methods. Okay. Coacervation is a polymer participation around the PCM droplet. So, that is on the PCM doublet the polymer is actually precipitate on that, and spray drying is one method. Then in situ polymerization, okay, capsule wall formed around the PCM, and fluidized bed coating. So, particles are coated with the help of fluidized bed or fluidized system. Fluidized polymer is coated on the particle, and the cell materials properties are basically that the polymer in the cells are polyurethane, okay, and melamine, formaldehyde, acrylic. So, good barrier properties, and it is a thermal stable. And inorganic cell material. So, one is polymer cell, another is inorganic cell materials, silica, calcium carbonate use advantage high thermal conductivity and durable. So, this type of cell materials are used to cover the phase change material. And how to integrate this with the textile structure? By melt spinning integration. PCM capsule is mixed with the polymer directly inside the polymer. In the melt spinning, that capsule is mixed with the polymer and then the extruded. So, permanent integration. So, it is not, it does not go off during washing. So, coating application, the surface application via padding, okay, and lamination process, it is laminated on the fabric. Highest PCM concentration can be achieved. Insulation panel, padding, and different applications, and foam incorporation. Through foam also PCM can be incorporated on the surface. So, the quality control, if we want to test the characteristics of PCM. So, encapsulation integrity. So, microscopic inspection can be done to assess the cell damage. PCM content, DSC analysis can be done for enthalpy measurement. Distribution, even actually we can verify the distribution whether the application is even, and thermal performance, heat storage or heat release capacity can be tested whether the PCM is working properly or not. So, PCM performance, real world performance and market application. So, the performance matrix, thermal temperature regulation effectiveness is measured by peak to peak measurement reduction. So, measured benefit 2 to 8 degree Celsius temperature regulation range, and that is it can actually increase or decrease the temperature by 2 to 8 degree Celsius, which is very good for any comfort application, okay, to enhance, to warm or to cool the body, and it can sustain, it can be up to the 15 to 45 minutes regulation duration. So, during that time the extreme condition up to 45 minutes it can keep the body warm, and 20 to 35% thermal comfort improvement, okay, and 1000 plus thermal cycle that we have already mentioned. And commercial application in military uniform, it is applied as in the base layer and insulation system, and thermal comfort is enhanced during the activity. Medical application it is used, it is a patent patients warming in application, and therapy garment there we can use. So, in patient those who are feeling cold, in those type of application we can use this PCM impregnated material and controls temperature therapy. It is the temperature therapy is being controlled, and sports application. So, performance wear, recovery garment, so temperature regulation is there, and occupational wear like your firefighter gear, industrial workwear. So, many applications we can use this PCM. Heat stress reduction is there for firefighter for extreme heat condition, and also for extreme cold condition we can use the PCM. Now, next material is aerogel. Aerogel is very light, as we have mentioned earlier. Structural characteristics: porosity is very high, 90 to 99% air by volume. Pore size is 10 to 50 nanometers, very fine pore size. Density is very low, and surface area is very high, surface area 60 to 600 to 1000 square meter per gram. The types of aerogel: one is silica aerogel, is there lowest thermal conductivity, but it is brittle, and carbon aerogel which is conductive, high temperature stable. Okay. So, for this is used for specialized industrial application. Polymer aerogel, flexible and easier process. So, that polymer aerogel is used for flexible application, and composite aerogel. Now, manufacturing method is by sol gel process. So, it is and first is the sol formation. Okay, the colloidal suspension is formed, then gel formation, cross linking, and it forms a 3D structure. Then aging process, network strengthening takes place by aging process. Then drying. So, solvent is removed, we get the aerogel, dry aerogel, and drying is by supercritical drying. So, that we use, or ambient pressure dry. So, the two methods of drying we can use normally, and the integration, how do we integrate? By particle integration. Aerogel granules are integrated in fiber or foam matrix. Inside fiber we can use composite blankets, aerogel sheet with fiber reinforcement, that we can use. Laminated structure, aerogel layers can be incorporated within the between the fabric structure, between two fabric layers, and coated substrate. Aerogel is actually used as the polymer coating, we can use aerogel particles there. And the performance characteristics, if you see, 2 to 5 times insulation improvement with the norm as compared to normal material, 50 to 70% thickness reduction. So, with lower thickness we can get equivalent insulation performance. So, there are different commercial products. Space Loft is a product, that is Pyrogel. So, this is silica aerogel composite blankets are used. So, if you see the comparison of performance as compared to other products. So, aerogel gives very low thermal conductivity. Okay, you can see it is lower than the even down feather. So, 0.03 to 0.025, and in down feather it starts from 0.025 to 0.28, and synthetic fill 0.03 to 0.05, and fleece 0.04 to 0.08 watt per meter Kelvin. So, this aerogel if we use it will give very lightweight and very high thermal insulation. In space application, extreme condition where weight is critical, in those in that application that aerogel is used. In industrial insulation, high temperature and thin material where it is needed, then we can use the aerogel. Specialty garment, extreme performance requirement with a lightweight. So, in those applications we can use the aerogel. The main application trade off is that advantage is superior thermal performance, thin profile 70 to 50 to 70% thickness reduction, temperature stability and hydrophobic properties. These are the advantages, but if you see the limitations, the most of the aerogels are brittle and dust formation takes place, that is these are the concern, and the aerogel is very expensive as compared to other material, and it is very difficult to manufacture, and it is not flexible. So, that aerogel will due to all these limitations we have to see the particular applications. Now, for extreme cold climate clothing, smart textiles are used, that is what are the smart textiles? The textile that can sense, react and adapt to the environmental condition for users need. So, that these are the smart textiles, like or the classification level passive smart, the only sense environmental condition. Okay. That is the passive. Active smart sense and react to the stimuli, that is active smart sensor, and very smart sense, react and adapt the behavior. So, this type of depending on our requirement we can use what type of smart material we want to use. Like the functionality, if you see, temperature responsive smart textile, that is shape memory polymer or thermochromic fibers or PCM integrated fiber. So, these are temperature responsive smart textiles. Moisture responsive, depending on the change in moisture, the response it tries to respond. So, like hygroscopic materials, selective permeability, wicking enhancement. So, these are the moisture responsive smart textile. Electrically responsive, like conductive fiber, heating elements, okay, sensor integration. So, electrically activated and mechanically activated, variable stiffness, shape change, support system. So, different types of smart integration is there, and we will discuss each and every type of smart textile, like heated textile system. So, heating principle, convert the electrical energy to thermal energy through resistive or conductive elements. So, heating elements are there, like metallic wire, like copper, stainless steel, like heating carbon fibers are there, conductive fibers are used, like metal plated textile heating zone, and printed circuits are also used, like conductive inks are used for printing, and then these heating elements are incorporated that with the system in components, that power sources are there, okay, and then control system. So, temperature control, so 3 to 5 heat level setting. So, different types of controls are there. Now, shape memory material in textiles, which controls the both the shape as well as the temperature regulation it can do. So, material types, shape memory alloy, okay. Then shape memory polymers are there, and shape memory ceramics. There are different types of materials are used. You can see the cold weather application. For cold weather application, adaptive ventilation is required. So, that is very important. Vent open and close based on the temperature for thermal regulation. So, it the shape changes, and which opens the vent, and when it is when it is hot, it opens the vent, so that moisture vapor and temperature can get released, and when it is cold, when we want to retain the body heat, that vents will be closed. So, that automatic adjustments are there with the help of shape memory effect. Fit adjustment is there, garment is tightened or loosed based on the environmental condition, like insulation control, variable loft insulation. So, that if we want to have more insulation, the loft will be increased and entrap more air, and if you want to reduce the insulation, that loft can be reduced. So, different and hood designs are there, automatic shape adjustment. Thermal insulation measurement method, there are different types of measurement methods in laboratory and field testing approaches. In laboratory testing, the control environment and standardized conditions are there, precise environmental control will be there, repeated test conditions will be there. So, in laboratory testing, in field testing, basically it is actual human factors are integrated, as we have discussed it is that wear trial technique. So, actual environment will be to the material will be exposed, the thermal insulation is measured at in actual environmental condition, like extreme cold climate clothing. So, we have to go to that particular location, like in high altitude mountain where the snowing is there, in those places we can use the clothing. So, human factors are integrated. So, and performance validation by the questionnaire, different types of questionnaire and body physiological measurement, that we can do in the field trial, and testing methodology, steady state testing and transient testing in dynamic condition. So, that we can use an ASTM standard for cold weather textiles. So, ASTM F1291 is a method which is a thermal resistance measurement by guarded hot plate system, okay. That measures the dry heat transmission. ASTM F1868, which measures the evaporative resistance, skin model and water method, where conditions are 35 degrees Celsius temperature in controlled humidity, and total heat loss is measured using the Manikin by ASTM F2732 method that and zone specific conditions are noted, and total body insulation is measured here, and air flow rate under pressure, air permeability is measured by ASTM D737. So, these are the different methods ASTM standard for testing the cold weather clothing. Now, guarded hot plate method, as we have already discussed, and where that the hot plate is there which is insulated and sample is placed, and then the heat flow is calculated. This we have already discussed, I am not going to discuss this again. So, this is the total heat transfer, directly heat transfer we can measure. Now, thermal manikin testing using the manikin, and we can have the walking manikin or also stationary condition, and this is used for building and automobile industries and clothing industries for extreme cold and extreme heat condition. Here this is the extreme cold climate condition. Here the skin is made of the porous material which resembles the human skin. So, salient feature of manikin is simulates the human body, the whole body or local part. So, human body heat exchange, number of individual regulated body segments are there, where the sensors are there at around 30 to 35 zones the body is divided into. It can measure the 3-dimensional heat movement. So, that is important. In guarded hot plate or other method, only one directional heat flow is measured. Here it is a 3-dimensional heat flow is measured. So, heat loss by conduction, convection and radiation is measured, and this is it can integrate the dry heat loss from the human body in realistic manner, and also the sweating manikin is there, where the water can come out and which simulates the sweating of human body. And another is the sweating guarded hot plate, which is almost same as the guarded hot plate, only difference is that the test plate is actually sintered plate, which is porous and through which the water can come out in other side, and the air flow, air and sample is placed over that, and during the air flow the heat will be taken away. So, we can control the air flow, we can have the without air flow for natural convection, and we can also measure the forced convective air flow, and evaporative heat loss is measured. So, water vapor resistance is measured here, and evaporative resistance can be measured, as I have mentioned, using the distilled water is in the dosing device, and this is the relationship, and the saturated air vapor pressure and ambient air vapor pressure PS and PA. So, RET is the evaporative resistance. So, using this relationship we can calculate the evaporative resistance of clothing material. So, air permeability is also tested. We can test the air permeability by normal air permeability tester. So, by this is the air permeability of fabric is a volume of air is measured in cubic centimeter passed through per second through 1 square centimeter of fabric. okay, and with the pressure difference of 1 centimeter water head. So, that is the air permeability that we can measure. So, the thermal insulation value TIV is the percentage of percentage saving of heat loss from the surface due to the covering with the fabric. So, that we can measure because heat loss per second from the uncovered fabric and heat loss per second from the covered fabric, okay. That we can measure. And for extreme cold weather protective clothing EN 342 is used. So, standard scope clothing protection against cold environment typically less than equal to 5 degrees Celsius, minus 5 degrees Celsius for occupational and professional application. So, this clothing classifies the system. So, cycle 1. So, this is ICLER, okay, that is the effective thermal insulation value for clothing. So, class 1 is that ICLER it is more than 0.31, this is the basic cold protection, okay. There is a protection level, and class 2 with more than 0.46 value, and that is that class 1 more than 0.31, which is equivalent to more than 0.2 kilo. So, we need for basic cold protection 2 kilo is required minimum, and for class 2 more than 3 kilo, and high cold protection it is more than 4 kilo is required. And air permeability classification class 1. So, it should be less than 5 liter per square meter per second, and class 3 air permeability it should be more than 100 liter per square meter per second. So, very porous. So, that we have to see the what our requirement, accordingly we have to select our clothing. And testing requirement thermal insulation is measured as per EN 342 thermal manikin or guarded hot plate, and the test condition is 10 degrees Celsius, and air permeability by ISO 9237 method. Okay. EN 342 we have this 343 weather protection standard. So, these standards are the water. So, the water resistant classification. So, water penetration is more than that this is water protection, water resistance to water protection WP. So, resistance to water protection is more than 8000 Pascal before penetration, and class 2 which is a basic water penetration resistance, and class 2 water penetration after cleaning. Okay, before pre-treatment, after cleaning it should be more than 8000, and good water penetration resistance more than 3000 Pascal, and high water penetration resistance more than 20,000 Pascal. Breathability classification class 1, water vapor resistance should be more than 4, limited breathability, and very high breathability it should be less than 15. So, that is RET should be less than 15, that means water resistance, the resistance to water vapor it should be there. So, accordingly we have to select which class we need. The comfort assessment method. rating scale, normally we use 7-point thermal sensation, cold or hot, and dimension comfort dimensions are thermal, tactile, ergonomic and psychological. And questionnaire design, standardized comfort assessment instruments are there. So, that we depending on the different types of comfort assessment. So, that we can use the questionnaire. Trial protocols, subject selection and study design. So, that different types of subject selection, representative user population sampling, like when if we want to use the for military. So, we use the defense personnel, we for defense if we want to use the do the wire trial. So, you should use the defense personnel. If you want to design the clothing for athletes. So, you must use the right population, athletes we should use. So, study design, randomized balanced experimental design, that we can use, and durability protocols. So, accelerated aging and long term performance validation we should do. So, thermal aging is done. So, in a extreme cold weather clothing, any clothing. So, at 70 degree Celsius for 168 hours as per the standard. Purpose simulates long term thermal exposure and UV exposure as per ASTM G154 UVB radiation, continuously UVB radiation is projected and material degradation is assessed. Thermal cycling, so it is a different range from -40 to +60 degree cycle. So, that the different types of thermal cycles 100 to 1000 cycle depending on application. So, at different condition these materials are cycled at different temperature, and chemical exposure. So, that test solvent and detergent resistant. So, assessment property retention measurement. So, that all this aging accelerated aging systems are methods are incorporated in testing. And let us see the 4 layer system evaluation. So, earlier it was a 3 layer, now additional layer for enhancing the moisture management and thermal regulation. So, one additional layer is incorporated. So, moisture vapor transport base layer is used, thermal regulation middle layer, and insulation layer which is variable, we can use the insulation layer accordingly, and environmental protection shell. So, that is the insulation layer we can add additional layer. So, here main advantage is that it enhance the performance, okay. Moisture management performance, improved vapor transmission through multiple gradients, we create the multiple gradients, and thermal targeted insulation for high to low heat loss area. So, at different thermal zones we can target. So, where the high heat loss is required or low heat loss is required. So, at that zone we can use that insulation layer, that is a 4th layer we can use. Modularity. So, this layer insulation layer can be removed or added depending on the application. So, the 4 layer systems are used even for other mechanical protection application. So, this variable layer is also used. And PPE compatibility and integration. So, integration challenge, combined cold protection with safety equipment without compromise either function. So, if we want extreme cold and bulletproof, suppose multiple integration is required and we have to integrate the obviously we have to integrate, but without compromising the function. So, PPE categories, head protection is also there. So, in that PPE we can add the head protection, hats, helmets with cold weather gear, and that will should not compromise the function. So, eye protection we can use the safety glasses, goggles, and respiratory protection, mask, okay, breathing apparatus can be used, and body protection, harness, vest over insulating layer. So, different types of additional layer may be integrated, and the modular hood system we can use pass through design, size accommodation and compatibility testing. So, that we can use this together, or along with the extreme cold we can use other type of protection. So, like modular hood system means removable, adjustable to fit various helmets. So, the different types of adjustable systems are there. Now, the military cold weather systems, extended cold weather clothing system. What is integrated clothing system for military operation in extreme cold condition, typically up to minus 54 degrees Celsius. So, these components are the layer 1 lightweight underwear, it may be polypropylene or merino wool. So, underwear which we use, it should be actually the wicking should be high, so that it should keep our body dry. Then insulation layer, so we can use a fleece and other things. Soft shell jackets, breathable, wind resistant. So, and hard shell material is there, okay, hard shell parka which is waterproof, windproof. So, different layers are used for protection from extreme cold for military. So, in those conditions outside there should be a waterproof or windproof systems, and effectively it should be lightweight. So, Arctic military operation, for that we need special type of clothing. So, which works from minus 40 degrees Celsius to minus 70 degree in this range with and with high wind and limited logistics. So, mission requirement is duration is there for 30 plus days, deployment in extreme cold, continuous deployment will be there. So, that we should have clothing which will at least last for more than 30 years, 30 plus days without generation of any microbial attack. Mobility, so full combat effectiveness and maintenance is there. Equipment integration, compatibility with weapons and gears. So, that different types of weapons and gears can be integrated, and logistics, a minimum supply and maintenance, because as we are the mission is at the Arctic zone. So, we cannot it cannot be replaced frequently, because supply will be limited. So, specialized gear requirements are there. The extreme cold boots are there, which will be vapor barrier system, minus 65 degree Celsius rating for at least 14 plus days. Arctic sleeping system, so minus 40 degree comfort rating, moisture management is there, hand protection gear and face protection. So, different types of gears are there. So, medical applications, for medical applications, medical cold protection. So, clinical application, hypothermia is prevented, and therapy garment, controlled cooling for injury treatment, recovery system, and post operative temperature management and emergency response. Okay. And for specialized medical textiles, so warming blankets are used, electrically heated, temperature control. Cooling vests are used for PCM integration, okay, targeted cooling zone, like here this is for specialized medical application, emergency wrap, okay, reflective barrier, or maybe compact storage or rapid deployment. So, what are the innovation trends in cold weather textiles? So, the future technology integration are actually it converges to the material science and nanotechnology and digital systems. So, all this are this is the direction where the research are going on. So, emerging technologies are nanofiber insulation, submicron fibers for enhanced thermal properties, graphene integration, enhanced thermal conductivity and strength, smart polymers are used, temperature response materials are used, and bioengineering material, protein based and bio inspired designs are used. Now, see the advanced technology. So, manufacturing evaluations are digital manufacturing enables mass customization and rapid prototyping. So, this emerging technologies are 3D knitting, seamless garment construction with integrated feature. So, that is this is the new direction of the cold weather clothing, advanced manufacturing. Digital printing is used for localized material properties and pattern, automated cutting and robotic assembly, okay, and customization capabilities. Body scanning systems are there, which 3D anthropometric measurement for perfect fit based on the different person and their body shape, on demand production, made to order, that type of for a particular person we can that made to order type of production is there, and performance zoning is the variable material properties based on the body heat mapping. So, before we go for the designing, so body heat mapping is done, and accordingly based on the particular person customized material protective garment can be produced, and feature integration, built-in heating, sensors, connectivity. So, immediate the heaters are integrated. If the temperature is dropped with us at below certain level, immediately that sensor will be excited, and that will be get activated, and heating will start. So, additional heating can be incorporated. Now, what are the opportunities and research gaps are there? Let us see that we can. So, critical areas for future investigations. Research priorities are fundamentals and applied research needed to advance cold weather clothing. What are these technology gaps? So, multifunctional integration. So, combining thermal, moisture and smart functions. So, that is that type of technology we should adopt. Durability prediction, long term performance modeling that one can do. So, how after certain time how the performance will be there, that can be predicted. User comfort model, individual thermal comfort prediction. So, for individual person, how that particular part, because every person will have their individual physiological response, like metabolic heat, sweat generation and different types of other physiological response will be there. So, depending on the individual person's physiological response, the comfort model can be developed, and then sustainable materials, bio based high performance alternatives can be developed. So, the research opportunities are biomimetic design. So, learning from Arctic animal adaptation for material innovation. So, we can learn from how the Arctic animals are adapted. So, accordingly we can innovate the material. So, we can integrate the artificial intelligence through machine learning for predictive comfort and performance optimization, that we can do, and circular economy. So, that closed loop material system and end of life solution. So, we can recycle and we can do the use the circular economy and extreme environments, space applications and next generation polar exploration. So, all these research opportunities are there. So, one can work, we should work in these areas, and the future industry direction, sustainability focus. So, circular economy principle, bio based material and reduced environmental impact. So, these are the for the industry, they should focus on the sustainability and the prioritization comfort fit solution and individual thermal comfort optimization, that is their they should prioritize, and smart integration, IoT connectivity and predictive the predictive algorithm and the adaptive performance. So, IoT connectivity, predictive algorithms and adaptive performance, that this all this smart integration we can incorporate, and multifunctional design. So, integration of protection, communication and heat monitoring. So, all this functional integration should be there. Now, the conclusion which we can make here from this course, this module, the comprehensive understanding of cold weather textile design we have made, and testing and applications that we have tried to understand, we have to get and measure. Learning points are human factors, we have learned what are the physiological response driven design requirement, and material science we have tried to understand what are the different types of materials are required for extreme heat protective clothing. So, advanced material enables superior performance, and the systems integration, holistic design approach critical for success, and different testing standard, rigorous evaluation evaluation ensures the safety and performance. So, different all these major points we have tried to learn here in this module. Now, ergonomic principles in cold weather clothing. So, human centered design is required. So, the science of designing equipment and workplace to fit the workers physical and cognitive capability. So, that is very very important here. Now, see here the anthropometric fit, that for any ergonomic clothing. So, anthropometric fit should be there, accurate sizing to reduce the pressure point and improve the movement. So, that is very important here, and thermal comfort, maintain core temperature around 36.5 to 37.5. It should maintain the optimized insulation, and it should preserve the mobility. It should not actually restrict the body movement by increasing the bulk. Okay. So, it should reduce the bulk, articulated pattern, okay, and microclimate control. So, microclimate maintains typically 32 degree Celsius and the 40 to 60% relative humidity, that is the comfortable zone. So, we should maintain try to maintain the microclimate within that zone 32 plus minus 1 degree. So, here it is typically it is a 31 to 33 degree Celsius we should try to keep, and cognitive efficiency, reduce fatigue, maintain dexterity for operational performance. So, that we should try to develop, and here anthropometric fit. So, population specific sizing is required for garment, pressure point should be reduced, layer interaction optimization, we should design the multi-layer fabric, and that interaction optimization should be there, and movement compatibility. The fit should preserve the natural joint articulation. So, that it should not restrict the body movement, okay, and pressure point should be reduced, and the layer should be actually interaction should be there, that optimization should be there. One layer if we add, that should not affect the performance of the other layer, that we should have this type of design. And ergonomic principles in cold weather clothing, thermal comfort, coat temperature maintenance is there, that 36.5 to 37.5, and heat balance should be there, and mobility, metabolic energy demand should be there, and the it should be mobility should not be restricted. So, if we have more this heat balance is not there properly, the physiological load will increase, and thermal sensation and performance. So, discomfort increases fatigue and reduces the physical and cognitive performance in extreme cold condition. So, that we have to maintain all these requirements, and mobility preservation is the range of motion, okay, impact. So, bulk insulation can cause 25 to 30% reduction in joint mobility. So, insulation is required, but if we increase the bulk, that will reduce the mobility of human being. So, ergonomic patterning is required, articulated joint, okay. So, that should not restrict the stretch, and material optimization. So, low bulk insulation is required where by using hollow fiber, spesser fabric reduce the stiffness and resistance, and performance benefit we should analyze. So, improve the mobility and lowers the metabolic effort and fatigue during physical tasks, and microclimate can be controlled. So, optimum microclimate is 32 to 34 degrees Celsius and 40 to 60% relative humidity. Heat and moisture balance should be there, it should regulate the heat and moisture properly, and moisture management prevents sweat to accumulate, and at the same time it should release the moisture vapor, and it should prevent the condensation. Okay. And cooling efficiency enhance, it is enhanced evaporative cooling, lower the physical strain during the physical activity. So, the cognitive efficiency is neurocognitive stability, it reduces the thermoregulatory strain to preserve the focus and execute the function, and decision accuracy. So, if we can keep the person comfortable, so we can take the decision properly, reduce the cognitive load, and the clothing should be able to minimize the mental burden caused by discomfort and fatigue, and its situational awareness maintains perception and task performance in demanding condition. So, that all these things cognitive efficiency can be increased by proper designing of clothing and enhanced ergonomic, and that in cold weather clothing we have discussed all aspects, and here we are will stop this module, and next module we will discuss in other aspects of human protection by textile material. Till then, thank you.